In this tutorial, I will show you how to create this database animation in Cavalry. I saw this image on Pinterest and I thought I could create the same thing in Cavalry and have it animated. So how do we do this? The best way to approach this problem is to split it in parts. For example, create the initial data points, data itself, and then connections, and finally assign different colors based on the data we're using. I'll make sure to include the final file in the description so you can download for free and pick it apart if something is not clear from the tutorial. I will start by creating a new composition, and first I'm going to create Ellipse. So data start. Then by holding Option key and clicking on the Duplicator icon, this ellipse is automatically input in the Duplicator. So we need to use linear distribution, and I'm going to use 5 connections and have it as a step. Okay, so first step is done. I'm just going to position it at the top. Now I'm going to create data point itself. So I'm going to link width to height, so then I can control everything from this one controller. Right click and add a random modifier to the radius. So we need to specify how big or small our ellipse will be. I'm going to pick something between 20 and 70. And then I'm going to put this ellipse into another duplicator. And as you can see, the sizes varies based on the duplicator index. So I'm going to use a point distribution. And what I want to do is stack the ellipses on top of each other like this. Now I'm going to look for Accumulator. And what the Accumulator does is simply calculates all the values that's being fed into it, and we can then use those values somewhere else. So I'm going to take radius width, plug it into the value, then take the whole accumulator itself and put it into shape Y. As you can see, every single shape is offset in the Y-axis. The problem is they are overlapping. This is because we're using radius, not diameter. To fix that, we can simply add expression, which essentially doubles the values that this field is receiving. It's kind of working, but the problem persists that some shapes are overlapping each other. To fix that, we have to add Align Modifier to our data point. Just drop it here. And simply shift it upwards. Now we have our data column ready. However, I don't want the pivot point to be at the very bottom of the duplicator. I want it to be at the top. So when I add more shapes or subtract, the duplicator will grow downwards. We can do this by adding another Align modifier to the duplicator itself, and then shifting it to -1. And as you can see, the pivot point is at the top. So now all the shapes are growing up and down, which is what we want. Okay, next step is to take this duplicator, hold Option, put it into another duplicator. And if we select linear layout, we can see everything is being nicely stacked. I'm going to change to step, change this as well. However, to make this a little bit more dynamic and don't worry about modifying the size, we can use this random value in the size field. Simply, if we grab the maximum value from the random modifier, drop it on duplicator, and then find find linear size, then this modifier will control the distribution for all the data columns. And now simply we have to add expression that will multiply this value twice, and now every single row is spaced out correctly. So if we change our random fields, they will grow and shrink and none of them will overlap. I don't like that every single column has exactly the same amount of data points. I would like to vary this a little bit, like randomize it. We can use the same random modifier to drive how many data points are in each column. Simply select our first duplicator, right click, add number range. So let me explain the number range. Number range simply converts the minimum and maximum values into new minimum and maximum values. In After Effects, you can do this with linear expression. So what I'm going to do is grab the minimum value from a random modifier, drop it on minimum, same with max, then specify how many shapes I want to distribute. I want to have a minimum of 3 and maximum of 10. And then I'm going to grab the random modifier and drop it on the value itself here. And as you can see, if I change the seed, everything changes, everything is responsive, and everything is driven from one modifier. Next thing that I want to tackle is the color of the data itself. So I'm going to create a color array. Color array is really useful because we can specify different colors here and then use them to drive how things are being recolored in our duplicators. So to make this clear, I'm just going to rename this. And you can change the color using this color wheel or typing in RGB values, hex codes, and so on, and drive the transparency using this slider. And we have option for adding hex codes and RGB here. So I picked a number of colors which I think will work well. Next is I'm going to add a background shape. This shape will automatically fit to your composition size. So I'm going to drop it at the very bottom. And then simply drag the pick whip to the background shape. And now from this single field, we can control a background color easily. To keep it organized, I'm going to rename the color 0 to background, color 1 to data min, and color 2 to data max. Now to randomly assign the colors to our data spheres over here, we can simply drag and drop the color array. But we have a problem because we're using the background color. So there's a better way to do this. So I'm going to go to Data Points layer, go to Fill tab, right click on the color and find field called Number Range. Now number range is useful because we can map numbers to a color itself. This works similarly as the number range we used before. So number range to color, I'm just going to pin it here, get our random modifier, plug in minimum to minimum, max to max, and then take the random modifier itself and plug it into the value. As you can see, our data is recolored nicely based on its size. So then I'm going to select my color array, pin it. Then I'm going to select one of the gradient stops and simply drag the pick whip from the data minimum color onto this field over here. Do the same opposite on data max. And as you can see, everything is being colored according to size, and we can even customize this to something like maybe 0.9 to ensure that anything bigger past this value gets maximum color, which is yellow. Now let's clean this up a little bit. I'm going to select my two shapes, Command G to group them. Put them at the bottom, and these two as well, group it. So for the next step, I'm going to tackle lines themselves. In Cavalry, we have something called Connect Shape. Now, this tool let us connect shapes with other shapes. You simply select your source and then target. So in our case, the source is the data start points. And then you use distribution. This is the same distribution that we have in Duplicator. So if I use submesh, simply drag the duplicator that controls position of these dots, then our connect shape will draw the lines from this position. And as a target, I don't want a circle, but I want to use submesh. Then I'm going to grab the data grid and drop it on top of it as well in here. So now if I move the data grid layer, the connection is being drawn automatically. Now we have a problem because I don't want these lines to be drawn to any other shape than the very top one. So to fix this, I need to be able to get position data of these individual shapes on top in this second duplicator. We can do this with Get Submesh Transform node. So if I drop my data grid here, we can see we've got some data coming out of it. Get Submesh Transform tool allows us to get position, rotation, and scale data and use it to drive something else. Now, how do you know which submesh index to use to get relevant position data, or which custom level to use to target specific shape in your duplicator? This could be a little bit tricky to figure out if you have a complex shape that is created from other shapes. Like in this case, we have a duplicator that creates a shape made of another duplicator itself. In Cavalry, we have something called Mesh Explorer. I'm going to pin it to the side. Mesh Explorer lets us figure out the indexes of every single mesh and then its child as well. So as you can see, we have submeshes, which is each column, and inside each submesh we have children, and they have indexes as well, 0 to 7. So if we take this submesh, set it to custom, and then we want to go one level below instead of 0 to 1 to target these submeshes, and then use index 0 to target the very first child over here. So next step is to use this data inside the connect shape. Going to close this. Go to target. Instead of using submesh, we are going to use an array. So if I take this position data and feed it here, we can see that everything is connected to this very first dot. So now if I select different submesh, this simply jumps to the relevant data point. And this is great because this way, no matter the position of this data grid, all the connections are targeted at this specific shape. I haven't figured out a way to automate this to create multiple arrays for every single column. So we need to rename the submesh to 0 to correspond to the submesh index, and then duplicate it 9 times, and then simply on every single submesh change the submesh index like so. And now back in our connect shape, we need to do the same thing and create a number of arrays and simply feed the position from every single submesh to position in the array. So I'm going to group this. Drop it into utilities because we don't need it. So next step is to customize how the connect lines look like. So on the first tab, we've got a bunch of settings. What we can do is use the auto bezier lines. And instead of using a shoulder target, we can use projection vector. Projection vector works with the projection target. So what does this mean is simply if you add something like a null, then you can customize how the Bezier looks like according to the position of this null itself. So I'm going to zero it out. You can customize this to its liking. S is for the start position, End is for the end point. But I'm going to keep it at these settings. And simply by moving the projection target null, you'll be able to adjust the curvature of the lines. Okay, to further customize the look of the lines, let's target how many lines are being connected from our data point to the data grid itself. What I mean by this is I want to randomize the number of lines coming out of each of the data points. We can do this with within range, because if I change the search distance to lower and lower, as you can see, we get less and less lines per point, but at some point they disappear. So around 300 is a good spot. So what we can do is simply plug in a number range, then grab our random modifier from the data point itself, just pin it here, number range, pin it, and then grab the minimum value from random modifier, drop it into the source minimum, same thing with max, and specify minimum from around 300 to 600 pixels, and then plug the whole modifier into the value. And as you can see, randomly we got multiple number of points coming in per data point. So if you play with these values, you'll be able to randomize how many data lines you get per point. I will leave it at around 550. Now in the stroke field, I'm going to change the cap to round because I don't like this weird ending. Rename it. And what would be cool is to assign a different color per line, depends on how many connections we've got. So we have 2 lines, they are a certain color. If we have, let's say, 5 lines, they are a certain color too. So we are going to do this with the same tool as before, number range to color. You can simply take the our search distance values, the previous number range modifier, and take the minimum values and put them into maximum values, and take the search distance modifier and drop it into the value itself. So what happens is, this is getting a little bit kind of complex, but we have our random modifier deciding how many connections each data point gets, and based on the number of these connections, we are automatically applying a color to it. I didn't want to first use the random modifier and put it into these values here first, because if I change the search min and max, I want everything to update, like so. And of course, the next step is to simply specify our color. So for data min, it's this color, and for data max is this one. And we can do the same thing for the size of the stroke. We can set a thicker stroke to data points that have more connections versus the ones that have less. So if we simply add a modifier number range to the stroke, spin it to the top, look for the search distance, then grab the minimum value, drop it here, maximum value, drop it here, and specify the stroke from maybe 2 to 10, that's fine. And then grab the search distance and plug it into the value. Now this is a little bit too thick. There you go. So the data points that have more connections have thicker color and a thicker stroke itself. And we can further customize it as well. Now, one of the last things I'm going to tackle is the size of these data points themselves. So I'm going to find our shape layer that is used to create these shapes, which is data start. Just pin it. I'm going to connect width to height, and then simply drop the radius into it as well. And we can use the same color node, which we use on the data points themselves, to simply recolor the top node. There you go. So everything is driven by one data point. You can change the seed number and everything updates accordingly. Okay, as a final touch, we can animate everything. So let's start with animating the data itself. Going to select data column. Then in the shape scale, I'm going to link X with Y. Click to create a keyframe. Go a bit forward in time. Add the keyframe. Set the first one to 0. Then select both of them, go to graph editor, and if I right click, select Bezier, just play with the handles a little bit, like so. And we have everything animating nicely. To offset this animation, we need to go to Data Grid layer, right click on Shape Time Offset, add a stagger. This will simply delay any incoming animation into this duplicator. So if I set this to something like 20, as you can see, everything's being animated from right to left. To flip this, we can simply click on the graph and flip it like so. And you can even further customize this with adding a Bezier to this delay. So you have a little bit of variation. We're going to do the same thing with data lines. Simply select data lines, go to stroke, find trim, and this setting simply allows you to trim this all the data lines all at once. So you can easily click on the end, maybe set it to 0. Again, in the graph editor, change the animation to Bezier and play with the handles. We have animation happening nicely. And we need to do the same thing with the time offset to add a delay in this animation. Can set it to something like 20 frames. And as you can see, we got the same problem. So we have to flip it, maybe like so. And what would be cool is if we could add some kind of variation between start and end, because at the moment everything comes at the same time. So what we can do is simply add a number range again to the stagger. Select it, find our random modifier, which we created at the beginning, plug in min to max, and have a delay of around 20 to maybe 35 frames. And then grab the random modifier, plug it into the value. There you go. So you're adding a little bit more variation inside the variation. And the final step is to animate the data start point. What we can do is find the shape scale, link it, then add number range. And what we can do is take the data lines, the stroke itself, plug it into the value, change the property from 0 to 100 because stroke goes from 0 to 100, the stroke trim property, this one, and then simply change the minimum and max from 0 to 1. So as you can see, the dots are animated using the stroke trim value. However, the animation doesn't match with the lines because we have a stagger applied to the data lines. So what we can do is select data start points, grab the stagger itself and feed it into shape time offset on the data start point duplicator. So now, if I scrub through, you can see how everything perfectly aligns. And we're pretty much done. And if you click on this button, you can see all the keyframes we created, and you can easily move them around, space them out, etc. And animation will update accordingly. And remember that everything is driven by pretty much one random modifier. Hope you learned something new, and if you got lost, make sure to download the project file from the link below. Thanks for watching.